Assalamualaikum and hi everyone. Today, our group will be presenting on how near-infrared or NIR spectroscopy can be used to predict sugar content in fruits. We are from Group 1 AS2534B1 and my team members are myself, Dhiadini Naqiyah, and my partner Firzana Huda. Okay, for my part, I will be presenting from the introduction up to chemometric data processing. Let me start with the introduction. Sugar content plays a crucial role in determining fruit quality. It affects sweetness, ripeness, level, and taste and overall consumer acceptance. Fruits with the right sugar level are more appealing and have better market value. Apart from that, monitoring sugar content is also important for health and dietary purposes, especially for people who need to control sugar intake, like patients with diabetes. Because of these reasons, sugar measurement is essential in agriculture, food quality assurance, and food industry. Next is importance of sugar content analysis. In agriculture, sugar content is used to determine optimal harvesting time to ensure better taste and reduce post-harvest losses. In the food industry, sugar levels must be controlled to maintain consistency in products like juices, desserts, and fruit-based drinks. Accurate sugar analysis ensure better product quality, consumer satisfaction, and health monitoring. Moving on to differences between traditional methods and NIR spectroscopy. Common laboratory techniques such as refractometry and HPLC are widely used to measure sugar content. However, these methods are destructive, time-consuming, require sample preparation, and involve chemical reagents. Because of this, they are not practical for rapid or large-scale fruit testing. However, near-infrared spectroscopy provides a faster, non-destructive, and more convenient alternative. It allows whole fruits to be analyzed without cutting or damaging them, making it suitable for rapid quality screening and field applications. This makes NIR technology increasingly important in modern agriculture quality monitoring. So, how NIR spectroscopy works? First, the fruit sample is placed under the NIR instrument without cutting or destroying it. The instrument emits the near-infrared light in the range of about 780 to 2500 nanometers onto the fruit surface. When these lights enter the fruit, it interacts mainly with sugar and water molecules, especially the OH and CH bonds, causing molecular vibrations. So some of the light is absorbed while the rest is reflected back to the detector. The instrument then records this reflected light and produces a spectrum showing how much light is absorbed at different wavelengths. Next, this spectrum is then processed using chemometric techniques such as partial least squares regressions, which links the spectrum to actual sugar concentration based on previously calibrated models. Finally, the instrument predicts the sugar level and displays the result as soluble solids content or bricks. Chemometric data processing. The raw NIR spectra cannot be interpreted directly. Therefore, chemometric techniques such as partial least squares regression are applied to build a mathematical relationship between spectral signals and reference sugar values. Model performance is evaluated using parameters such as correlation coefficient, prediction error, and robustness to ensure accuracy and reliability.
Hi, I'm Firzana Huda binti Hambali and I will continue about the critical review of the journal studies. Before we continue to the journal reviews, let us recap on how NIR analysis works. NIR analysis, which is near-infrared light, is directed into a sample. The sample absorbs and reflects part of this light depending on its chemical bonds. The reflected or transmitted light is then detected and converted into a spectrum which is analyzed to determine the sample's composition. For critical review of journal studies, we have found 2 journals that use NIR instrument. Previous studies show that NIR can accurately predict sugar content in various fruit. Thus, the first journal is about prediction of sugar content in Java plum using NIR. NIR will generate 2 spectrums which are first and second derivative. The first derivative will show uncorrected baseline, while the second will show the corrected baseline and accurate spectrum. So before we take a look at the spectrum, the functional group that must obtain to determine the presence of sugar are CH bond and OH bond. Then, let us take a look at the first derivative spectrum where the peak obtained is 1450 nm, which shows OH bond, and 960 and 1200 nm, which shows CH bonds, which these bonds absorb NIR at specific wavelength due to vibrational overtones. On second derivative, which give the best sugar prediction, which at 1450 nm and 960 nm. We also must use preprocessing methods to remove scattering effects, improve baseline drift, remove noise in spectrum. Method that we can use such as MSC to remove scatter. The second one is Savitsky, which enhance peaks and normalization to improve model robustness. As we can see from these both scattered graphs that have been obtained, the second derivative spectrum shows better best fit line and the PSLR obtained is 0.55 and CNN and LSTM obtained is 0.83 by using the model comparison method. Moving on to the next journal that we found, which is Assessment Quality Parameters in Javadi or Peach Fruits using NIR. As we can see in Table A, which is first derivatives, and other tables with additional method use. From the Table A, we found that spectral range is between 350 nm to 1150 nm. These studies use preprocessing method to eliminate background noise and improve the resolution of overlapping peaks. The method used such as Savitsky-Goulet, which also to reduce high-frequency noise. The second one is MSC to correct light scattering effects, and others combined methods. Lastly, moving on to the improvement and outlooks. For example, by optimizing wavelength selection, which helps in reducing noise and improve prediction accuracy. Next, by using advanced preprocessing techniques, which improves peak resolution and removes water dominances. Lastly, for outlook, by using cloud-based databases, which helps improve model transferability across region and food types. In summary, NIR spectroscopy is an effective, non-invasive technique for estimating sugar levels in fruits. Although it has certain limitations, continuous advances in chemometric methods and instrument technology are enhancing its potential, making it available tool for future use in agriculture and food quality assessment.
We use NIR spectroscopy to explore light from 200 to 2500 nanometers, from ultraviolet to visible to near infrared. It can handle everything, small samples, big samples, and even measures from different angles without moving your material. From coatings to solar energy to optical research, it's how we test, refine, and innovate with precision.
It's the end of our presentation. Thank you for watching and listening.